Let's find out the time complexity of the code snippet. By observing the code, we can see that there is one loop, and our variable I starts from 2 and gets updated 3 times in the loop. Since I is updated 3 times in the loop, we can find the effective value of I after all the updates. The 3 updates of I can just be simplified to I to the power 25 of power by 3 of powered by 1/25, or I to the power of 3. We call this as effective value of I. We can replace the 3 updates of I with the effective value of I. Now our function looks like this. Loop will run until I is less than n and terminates when I reaches n. Now, we will find the last value of I, which makes the loop to terminate. We check the value of I iteration by iteration. The variable I starts at 2 and gets updated by the power of 3 iteratively until it reaches n. For iteration 1, variable I gets updated to 2 to the power of 3. For iteration 2, variable I gets updated to 2 to the power of 3 up to the power of 3. We repeat this until the last k iteration. We can simplify the values of variable I at each iteration. For iteration 1, it can be expressed as 2 to the power of 3 to the power of 1. For iteration 2, 2 to the power of 3 to the power of 2, and so on until the last k iteration. So, the last value of variable I which terminates the loop is 2 to the power of 3 to the power of k equals to n. Now, let's calculate the value of k, which is the number of iterations in the loop. We start by multiplying with log base 2 and then with log base 3 on both sides to get the value of k. Finally, we find the value of k. Thereafter, we can conclude that the time complexity for this code snippet is the number of times loop executes, which is k or log n. And we can express it as big O of log base 3 of log base 2n.